Hello, everyone. Okay, beautiful. How are you? So, for those who were here in the morning panel, I assure you this is completely different. We're not talking about AI, a little bit at the end, but I want to mostly introduce a thesis to you, a problem that concerns all of us, and the solution that Vijay and I and our team have been building at Founders. So, I want to start very simply and clearly, as much as possible. Internet freedom cannot be guaranteed behind walled gardens. I think this is evident for most of you here. And there is something even worse to say about those walled gardens, which is they limit the type of global coordination and collaboration that we can imagine, and let alone realize. And crypto is all about solving global coordination and collaboration problems. Games. Now, the problem speaks for itself. I'll give you some details, but in just 2 minutes of research on Google, you'll realize that your tools, your favorite tools, are leaking data constantly. They're censoring you. Your account is not really your account. It's an entry on somebody else's database. And this leads to a bunch of known problems, like the one that happened yesterday, where a huge company lost all their data that they were storing on Google and the backup data that they paid Google to back up on top of it. So, just to give you a bit of an overview of the main issues that come with those centralized collaboration and storage tools that you're using, you're at the mercy of mass surveillance and the behavioral manipulation that comes with it, arbitrary decision from somebody in the company or a disgruntled employee that wants to fuck shit up before they leave. You have insufficient or complete lack of encryption, let alone end-to-end encryption. You have link rot, which is very related, which, fun fact, 38% of all content that you had on the internet in 2013 doesn't exist anymore. So this is a huge problem for academic, journalists, etc. You also have a problem, the possibility of the company going bankrupt, getting bought, leaks, server outages, user lock-ins from the design of those apps, and finally, constrained ownership configurations, meaning I want to share a Google Drive with the people I interact with most on my favorite subreddit. Impossible. But we can do that now with multisigs for bank accounts, for digital bank accounts. So I want to keep those reference points and explain how we're approaching them in order to explore not only a way to solve all those issues, but actually also open up a design space that is completely unique and allows for group collaboration. Now, 3.2 billion people around the world are dependent on 2 companies and a few servers in the US mostly to create, store, and share information. For crypto teams, individuals, communities, it's the same issue. We should know better, but we couldn't do better. At most, what you could do is use a file-sharing peer-to-peer network like BitTorrent, or maybe use a privacy-enhancing centralized collaboration suite, but they were each solving different problems. One is an open peer-to-peer network. The other is centralized technology. It provides privacy, but it has a lot of the issues we just went over. Now, to avoid capture altogether and the abuse that comes with it, we believe that our most essential activities and data should leverage open protocols and networks instead of closed products managed by centralized companies. Thankfully, we're not starting from zero. I think that it's been now 40 years, 45 years, give and take, that the open source community, the cypherpunks, all those people that we admire, we're thankful for everything that they established to create a crypto industry on top of them, have been trying to create the types of tools that I'm describing to you today, or the type of infrastructure that I've been describing so far. But they've been depending mostly on distributed systems, on peer-to-peer networks, some access control management, and inevitably some centralized servers to do essential tasks or essential permissioning that you could simply not do with the tech that was available until now. And then community computers stepped in. I like to use that term. It's not mine. It's Ethan Buchman's from the Cosmos community that I first saw using. He describes it as personal computers unleashed unimaginable levels of sovereignty and interoperability for people. Think the iPhone. And community computers will do the same for groups. So now we're talking about an architecture that is a bit more developed. There's something missing here. That is a bit more developed than what we've had until now. So it's not just peer-to-peer networks anymore. People could have their own public and private key, which is a great addition to peer-to-peer networks if you want to be self-sovereign. But there is a last element that we consider extremely important to create a more universal public good infrastructure for any type of collaboration between people and management of knowledge, and that's public blockchains. So on this slide, there should be a second column where I describe the properties and the advantages of both public blockchains and peer-to-peer networks. I'll just go over quickly why we think that the combination of both basically allows us to create completely new types of applications, unlocks completely new types of interactions between people, and what we like to call self-sovereignty. So public blockchains provide you with global consensus, strict global consensus. It enables objective identity. It's one of the most important properties is the credible neutrality that comes with public blockchains. You have computational and data integrity, and it allows mostly for some type of inter-app composability through smart contracts, for example. OK, we're missing one column. So this is the thesis. I'm going to pass on to Vijay to explain to you the architecture and how we're putting all that together. But I want to leave you with that mental model. We've had peer-to-peer networks since forever, good cryptographic tools as well. They weren't enough for us to simply replace Google Suite, Notion, all those amazing apps we're using all day, but that are basically working against us. And now with public blockchains, we think that by merging the two, we can create a new type of infrastructure that can unlock a bunch of new activities, coordination, etc.
All right. Let's see. Next. Yeah, and thanks, Andres, for doing a perfect job of explaining the vision of Fileverse and what we are trying to do. Now, what I would like to go into is a bit of a detail of what powers that vision, and as in like why we flex our tech in general, and to highlight different components that we have. The one component that we have is the off-chain component, where we mainly rely on peer-to-peer technologies. For example, IPFS nodes, gun nodes, and different peer-to-peer systems that we are using for powering this off-chain infrastructure. And then we have the on-chain component. The on-chain component is the component where we are storing things like let's say if you have the pointer to the storage, if you have the registry for identity, and if you have the address of the multisig that you're using to control your fileverse stack in general, and the permission registry in general, that's the on-chain component of fileverse. And then we have the app layer, and this is the most worked upon layer, if you will, from our side. And this is something where we are working on different UXs, where we are working on different patterns that we have developed for allowing users to interact with the above-mentioned on-chain and off-chain stack seamlessly. And yeah, so after working on the previous stack that I was explaining, we came up with the different different common primitives that we are using for our own self, meaning while we're building the fileverse infrastructure, we figured out there are few common pieces that can be used by other teams as well. And since they have been developed by us for our own use case, why not make it available to everyone else? And the main work on the fileverse protocol that we are doing, you can categorize it into 3 different layers. The first layer that you have is the identity layer, then you have the storage layer, and then you have the collaboration layer. We'll go into the details of each one and what are the specific primitives that we have developed to power these layers. So first one is the identity layer. In this, we already know about EOAs and multisigs. We're using them to allow you to control your fileverse stack and fileverse smart contracts. This is the new work that we are doing with respect to programmable identity. It's something that's based on Safe's work that they have done for ERC-4337 wallet. But we are combining the cryptographic access using encryption keys and the signing keys with the recovery, multiple recovery strategies that can be automated and are not assuming, let's say, that it's the person that's going to use that, and they can be used within the code without relying on human interaction. Then we have the storage layer, and in the storage layer, there are 2 components, like 2 high-level categories. One is the on-chain storage, and the other is off-chain storage. In the off-chain storage side, what we are doing is we're relying on peer-to-peer systems. And on the on-chain storage side, where we have worked on this collaboration smart contract, which allow for these peer-to-peer systems to agree on a state. And what this offers is it allows you to take your data, move to a different person or different peer or different network altogether without compromising or losing any data in the process. Then we have the collaboration layer. And this is the most interesting one because there is one big piece that we recently figured out with the help of different teams that we are working with. The first one is the collaboration smart contract, which is what I was explaining with respect to storage, permissions, and this is something which is giving us the data neutrality for giving right to exit to the users. Then real-time collaboration, in this we have this piece we have figured out recently, and in this we have peer-to-peer collaboration with end-to-end encryption, and also adding the offline first support with the browser, with the users being able to open that document into the browser as well and continue their work. I'm going to explain these things in the workshop, which we'll have later at the DappCon and one at the SafeCon. Then I'll let the looking for.
Yeah. Yes. So just to summarize, you've heard the thesis, you've heard elements about the architecture. Let me put all that together once again. So today, we're all depending, 3.2 billion people are depending on Google Suite and Microsoft Office for their daily activities, preservation of knowledge, etc. For everyday people, that's fine. There's still a lot of issues that are affecting people seriously. For crypto teams, it's catastrophic. For communities, no need to even talk about it. Those tools are simply not made to serve the needs of a decentralized community or a group that gets together. Maybe some of them are anons, they want to collaborate, but they cannot co-own the storage space, the documents that they share. The combination of peer-to-peer networks and public blockchains allows us basically to serve the needs of all those people, not just crypto teams and communities, but everyone that depends on those tools for their daily activities. It gives them the right to exit. No need to use our app if you don't want to use our app. You can continue using the access permissions that we've perfected for you. You can continue using storage that we've perfected for you. You can continue live collaborating with 10, 100 people on the same document without ever needing to hit one of the Fileverse servers. So really, it's that right to exit and composability that we've finally put together. And there are a lot of really cool use cases that are opening up with those. I won't go over the ones you're familiar with. I'll just cover a few. For example, the Fileverse stack at the moment can be used permissionlessly with Farcaster. Two protocols interacting with each other. You can put all your documents, favorite files, links, etc. on a Fileverse portal, smart contract. And even without using our own app, you can create, for example, a frame that goes through your content that you've stored somewhere directly on Farcaster. It also means that you can plug Fileverse smart contracts in crypto-native social media without ever needing to request permission to anyone. This also means that we've created a new primitive almost on chain, which we call collaboration smart contracts, but that also act as registries for content hashes that you've stored somewhere off chain. And this has been quite useful for teams that are experimenting with Onchain AI agents, actually. So I think you're all very much aware that most blocks produced today in public blockchains don't just have financial transactions and interactions occurring, they also have a lot of content hashes and pointers to certain media, to certain types of interactions, etc. So those AI agents can also interact with this type of content, store and give a representation of their activity on-chain, and have access to their own storage space off-chain without ever needing to get a user involved, go through a KYC process, sign up on a centralized app, etc. So just to make it extra clear, I want to give you a quick demo of the first building block we're releasing today. It's a decentralized app. It allows you to do everything you do today with Linktree, but instead of just having links, you have a decentralized web page. You can add your favorite links, documents of yours, files, images, videos, and all that without ever needing a server. And on top of that, you can invite people, give different access permissions to different people, again, without ever requiring to interact with one of our servers or fearing that you might be locked out of your account at some point because of X or Y reason. Just doing a quick sign to the tech team. Is it possible to get the video going? Hello, is it possible to get the video going? Super. Okay, I hope you enjoyed that. I'm sure some of you recognize the music that was in the background. But this is just a first view of what we're releasing, the first building block that we're releasing. You can scan this QR code if you want to try it out. It will only be open today for a few hours to get an initial wave of first users, get feedback, be able to interact directly with people, and not just onboard everyone in crypto before we are ready to actually make this completely permissionless. Voila, thank you so much.
Thank you, Vijay and Andreas. We have a few minutes for questions. Right here in the middle.
I was interested in like the storage you were using. You had IPFS and like Arweave and then et cetera. Is there any option for like local storage? So say if like you and I want to collaborate, but I don't want to put it on a public network, I want to just store it locally, and yeah, how does that work?
Yeah. So.
Yeah.
Yeah, so what we are doing is like the way that we have written the architecture for our storage layer, as you can say, is by writing adapters. And different adapters can store things to different places. One of the adapters is IPFS, other is Arweave. The one adapter that we really like to use is IndexedDB as well, like meaning you could do things on your browser side if you need.
So yes, local storage as well, but we wanted to make sure that we didn't just reproduce types of peer-to-peer apps that you would download a local app, which are great, provide a lot of security, privacy, etc., but that are simply not accessible to most of people around the world. Most people use Google Drive or Google Docs by going directly on their browser, accessing that.
Yeah.
And yeah, that's it.
All right, give it up for the Fileverse team. One of the most important projects on Gnosis Chain.